You want me to go in order and get as far as I can? Yeah. We may or may not get through them all that way. Okay. There may be a video from last year out on the old Weebly site, so you might want to check there. Okay, we got to find the derivative of the function. All right, so to find a derivative, and there's going to be some that are basic like this. There is one on the test where you have to do the limiting process, okay? Obviously, you're not going to type that in online, okay? You're going to write it on your paper, and I'll grade it from your paper, okay? All right, what are we going to do with this 8? Move it to the front. And then what do we have to do to the exponent? Good, and what do we get? 7. Hopefully we would get one like that correct, okay? All right, number 2, we're still finding the derivative of the function. What are we going to do with this? What are we going to get for the derivative of 2x cubed? Good, minus what? 2x plus 3, done. Again, you bring it to the front, multiply by whatever the coefficient is, and then subtract 1 from the exponent. Okay. We got it? Yeah? Should have 1 by the limiting process somewhere. I thought. Okay, next one. So, what do I need to do with this first? By making it what? Negative, and then we take and move it in front. So we've got y prime equals negative 7x to the negative 8, and then likely if that was multiple choice, you'd see it written like this as the answer. Oh, there is one. Okay. All right. I don't know why they're not in order. It started with page 115 and eventually goes to page 104. I have no idea what happened, but oh well. It's what it is what it is. Because I was looking, there should be one by the limiting process here somewhere. All right. So what are we gonna? What's the derivative of x squared? 2x, and the derivative of cosine is what? Negative sine x. The double negative is going to go positive. You do need to know the derivative of sine, cosine, tangent, cotangent, secant, and cosecant. There is a question that just literally asks you to write down the derivative of those. So you need to make sure they're memorized. Okay? Don't miss that question because you're going to be lazy and not memorize. Okay? You need to know those ones. All right? Remember, if it starts with the C, what do we know about the derivative? Negative. It's negative in front. Okay? So make sure you're looking those up tonight and you're getting those written down and memorized. All right. Find the slope of the graph of the function at the given point. We're not going to use the calculator at all tomorrow. Okay? So there's no calculator problems. It's all by hand, so the numbers are nice. Okay? So to find the slope, we need to take the what? Derivative. Okay, so I'm going to, before I take the derivative of this, I'm going to move it upstairs. So f of x equals 3x to the negative 2. Take a derivative, we put this where? In the front. So negative 2 times 3 is what? Negative 6x to the... And before I plug in, I probably would move this back downstairs. What are we going to plug into it? 1. So f prime of 1 equals negative 6 over 1, which is negative 6. There isn't anywhere to plug in the y, right? At some point, there will be. We're not ready for that yet. Okay? But right now, whatever they give you values for that, or whatever they give you space for, that's what you plug in. Okay. Determine the points, if any, at which the graph of the function has a horizontal tangent line. What's the slope of a horizontal tangent line? 0. So this is where I take the derivative and I set it equal to 0. Okay, so we've got y prime equals, we're bringing the 4 in front, so 4x to the third 2 times 8 is what? 16x, and then what's the derivative of 2? 0. So I'm now supposed to set that equal to 0. Okay. What is your greatest common factor? 4x. And we're left behind with x squared minus what? 4. I don't really need to do zero product property. We're going to, I'm sorry, I don't really need to do difference of squares because we're going to use zero product property. It'll take care of it. What do I need to do to move the 4? Divide it. So you would, what do you get? 0. We're going to add the 4 and undo the squared. When I undo the squared, what do I have to write in front? Plus or minus. So x equals plus or minus 2. Okay, but it doesn't just say the x values. It says the points. So how do I get the points? I got to plug back into that original equation. Good. So when I put a 0 into here, what do I get out of it? 2. So my point here is off of this is 0, 2. Okay. I'm going to plug a positive 2 in. See if we can do this without writing it down. So 2 to the 4th is 16 minus, let's see, 2 squared is 4 times negative 8 is 32 plus 2. So negative 16 plus 2 is negative 14. It's even exponents. Is that going to be any different for the minus? No, so couldn't I just write this? Yep. Okay, if it had been an odd exponent, it would change our y value. Okay. All right, we good with that one? Okay. Vertical motion. So they gave us this funky equation. We're gonna, you guys, if I give you one like this tomorrow, I would give you the information. I'd give you the function. I wouldn't make you try to sub into anything. Okay. So use the position function for free falling objects. To answer the question, it tells us, give it a second here, it's going to flip into, come on. Oh, that's not good. Clicked too many times. Oh, wait, it's coming back, it's coming back. There it is, resume slideshow. There we go. Okay, so, shh. See if that's back. Okay. A silver dollar dropped from the top of a building that is 1362 feet tall. That is this piece right here. So we don't use the middle. Our actual position function is negative 16t squared plus 1362. If I give you this problem, I will give it to you like that. I won't make you try to figure it out. Okay? It wants us to know the position and velocity functions for the coin. Well, I just wrote the position function, didn't I? All right, so the velocity function, what do I have to do to the position to get velocity? Find the first derivative. So what's the derivative of 16t squared? Good, and the derivative of 1362? 0. All right, so we've got the position and the velocity. Part B says determine the average velocity. Average velocity means use the slope formula. Okay. So we're going to take this and plug it into here to get our y values. And then I do 2 minus 1 on the bottom. So when I plug in a, and again, we're not using calculator, but it would be nicer tomorrow if I give you this one. If I plug in 2, we'd have what? 2 squared is 4 times negative 16 is what? And then 1362 minus 64 would be, good, minus, we're going to put a 1 in there, so it'd be 1362 minus 16 would be 13 minus 16 is 46. Is that right? You guys can, if you have your phone calculator, you can use that always. Right now, not on the test. All right. 1298 minus 1346 is? It's negative, yes. 30, 40. It's got to be more than that. Did anybody get it? Negative what? 40. It shouldn't be 12. 48, we think? 1296 minus 1346. I got 50. I did something wrong. Hang on. It's not 50. 1298 minus 1346. I got negative 48. We're good. All right, negative 48, but it would be in, it didn't give us, oh, it says feet per second. Okay. All right, part C. Find the instantaneous velocities when we've got t equals 1 and t equals 2. So instantaneous means take the derivative. Okay? So I'm going to take the derivative. I've already got the derivative, don't I? What do I need to do with these numbers? Plug them into that derivative. So the velocity at 1 is negative 32 times 1, which is negative 32 feet per second. And the velocity at 2 would be negative 32 times 2, which is negative 64 feet per second. Okay. Because we're not at acceleration. Okay. Second derivative, it gets squared. All right, find the time required for the coin to reach ground level. Okay. The coin reaches ground level when the position is what? 0. So I would take my position function and I would set it equal to 0 and find the time. So negative 16t squared plus 1362 equals 0. I'm going to move the t squared part because then I keep it positive. All right, we divide by 16. Let's see. 1362 divided by 16. I'm getting 85.12. 0.125. Is that right? Okay, and then we got to take the square root of that. You know, you turn your phone sideways and it gives you the scientific calculator. We don't want the plus minus, right? No. So 9.226 seconds. And then it wants us to find the velocity of the coin at impact, so I take that time and I plug it into, nope, the velocity, right? Because it's the coin at impact. So part E, I would be doing the velocity of 9.226, or probably more decimal places than that, but we'll go with the 9.226. So that would be negative 32 times 9.226 times 32. I got negative 295.242 feet per second. What? I'm taking my surface. That's it. All right, we good with that one? Okay. Looking at this next one, they gave us that same function again. I would give you the actual equation. A projectile shot upward from the surface of the Earth with initial velocity. So this time I would be plugging into my velocity. So S of t equals negative 4.9 t squared plus 120 t. What is the velocity after 5 seconds after 10 seconds? So even though it gave us velocity, that was just an initial velocity to plug into this function here. They didn't give me a height. Okay? What do I need to do to position in order to get velocity? Take the derivative. Okay? So what's the derivative of this piece here? 4.9 times 2. What is it? 9.8t plus what's the derivative of 120t? 120. All right, and then what do I need to do with these numbers? Plug them in, right? So we've got 5 equals negative 9.8 times 5 plus 120. And then somebody do that in your phone calculator since I didn't get out the other ones. 10 plus 120. So that's 98 and negative 120, right? So is that 22? Yes. Yeah? The second one. What's this one here? Anybody get it? 40. Is it 49? No, it's 71. We sure?
No, plus 49 minus
49. 0.8 times 5 is 49 plus 120. No, it's negative 49. minus 120, because there's a negative 9.8. 71. And then what should we write it in? What's our label? Meters per second. Good. Nope, not squared. We only square acceleration. All right. This one here. Now I'm back on page 104. I don't know how that happened. I just have the PowerPoint out of order apparently. So, we've got to find the slope of the tangent line to the graph at the given point. When we were doing page 104, this is when we did the limiting process. I only want to see the limiting process on the one problem that says to use that. Other than that, you're using the shortcut. So when I'm looking at slope, what are we actually doing? Derivative. Okay, so I need to find the derivative of this function. So f prime of x equals, what's the derivative of 3? What's the derivative of negative 2x? Okay, is there anywhere to plug anything in? No, so the answer has to be, please don't get that wrong. Yes. You'll see. Here it is. By the limit process. Okay? So remember when we had the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x? That is the definition of the derivative, right? So you have to prove to me that you've learned how to do it this way and prove it to me one time on this test. And then we never use it again except for seeing that setup on a few multiple choice problems down the road. Okay? So, you're going to see this on the test. It is there. I guarantee it. Okay? So make sure you can do this problem. All right? But it's weighted the same as all the other problems. All right? So, I'd make sure I can do it, but if I mess it up somewhere, I'm not panicking about it and spending the entire test on this one problem. Okay? I think there's about 19, 20 questions on the test. Okay? All right, so I'm going to start by taking this function. Hopefully it's a nicer one and we don't have to cube it, right? Do you guys have your notebooks? Open your notebooks and find that first page of derivatives. And remember how we cubed it and we did it that one time? Let's cheat. Not that I would say to do that on a test, but... All right. I said cheat on this piece, on the homework, on this. Hopefully it'll be squared on the test. I'll double check. Make sure it is. Anybody got it? What page is it on, Ruben? 50. Look in page 50. Okay, do you see one with a cube in it? Remember what we have to do first is we have to take this thing here and plug it into the cubed, right? X plus delta x cubed. So actually, let's write that out. X plus delta x cubed minus 12x plus delta x. So I plug the x plus delta x into the function the way it looks. Then I subtract the function the way it looks with the x's in it. All over the delta x. The goal is to cancel this delta x in the bottom, right? So the next thing I need to do is cube this, which means I have to multiply x plus delta x times x plus delta x times x plus delta x, which was kind of a pain. And we've done it before, and it's just an algebraic process, so that's what we're going to read out of our notes is that piece. So I know it starts with an x cubed. Anybody see it?
Yeah, it's x cubed.
Yep.
Plus 3x squared delta x.
Mm-hmm.
Plus 3x delta x squared.
Good.
Plus delta x cubed.
Delta x cubed.
So you just
Do what? Yeah, I foiled these guys, and then after that I have a trinomial times a binomial, and I use the box. Okay? But that's how we got that, and we've done that in your notes before. All right, we need to take that negative 12 and do what with it? Distribute. So negative 12x minus 12 delta x. And then what are we going to do with this negative here? Distribute it. So negative x cubed plus 12x all over delta x. Okay, and remember that limit part goes all the way down in the front. We don't want to lose it until I actually take the limit. So I've got the cubes that are gone. What else is gone? 12x. Okay. Looking at what's left, what can I factor out? I'm going to take out a delta x. Okay, I'm not worried about a 3. Well, there's no 3 in front of this one, right? So I couldn't take it out anyways. Our goal is to get rid of the delta x. All right, so what is, I'm left with 3x squared
plus 3x
plus 3x delta x
plus delta x squared
plus delta x squared minus 12. All right, what happens with these delta x's? Cancel. And then I am plugging 0 in for my delta x's. So I'd plug 0 into this and 0 into that. I'm shortcutting it a little bit here. So what am I getting for this piece here? 3x squared. What happens to this term? 0. And what happens to this term?
0.
And then I'm left with...
Minus 12.
Here's the nice thing about this. I could take the derivative the shortcut way and check it, couldn't I? So you should know what the answer should be. So am I really grading your answer on this? No, I'm grading that you can do these 3 steps in here.
So if this was a multiple choice.
It's not multiple choice. It is free response, okay? And I will try to remember to look at the end. I don't think it's going to be a cubed. I'll double check it, okay, here in a few minutes. All right. In excerpt, so we're supposed to find equation of a tangent line that's tangent to the graph of f and parallel to the given line. What do we know about parallel lines? They have the same slope. So I'm going to take this y and move it to the other side by adding. What's the slope I'm going for here? 3, right? Because the slope is in front of the x. Y equals mx plus b. All right. So equation of the tangent line. I need 2 things to find equation of the tangent line. What are they? Point and slope. I have the slope. I have to get the point. How do I get the slope out of a function? Find the derivative. Good. So what's the derivative of this function? Good. I need to take that and set it equal to the slope to find my x value, because I'm trying to find my x and my y right now. What am I going to do with the 3? Divide. So 3 divided by 3 is 1. Undo the square. Uh-oh. How many lines am I going to have? 2, because I just got 2 x values. So how do I get the y values? We're going to plug into this original equation. So f of 1 equals 1 cubed, or 1. F of negative 1 equals negative 1 cubed. What's negative 1 cubed? Negative 1. So our 2 lines, so this is my final answer in this box here. Y minus my y value 1 equals my slope 3 times x minus my x value. Y minus my y value negative 1 equals 3 times x minus my x value. Those could go positive. All right, we good with 33? Yeah? All right. 53. Identify a function f that has the following characteristics, then sketch the graph of the function. Okay, so it says that I have this point 0, 2. So I'm going to go out 0, up 2. So that point is on the graph. What is it telling you the slope of the graph is? Always, right? That's what negative infinity to infinity. So it must be a line. So I'm going to go down 3 and over 1 and draw a graph. That's it. What? If you have to draw your drawing on your paper, it might be identify, pull one of the multiple choice out. I don't know. I don't remember off the top of my head. Yes, Ruben.
So when you're finding the derivative of a function like that, the slope of that
This whatever the
function
derivative
zero.
is the slope.
What?
Huh?
What?
Whatever the derivative
Okay, yeah.
is the slope.
Yeah. But where would you put the, like, on which y point would you put it?
Whatever the y value is that they give, whatever point they give you, you count your slope from there. Okay. Let's see if is there another one like that. Oop, there's another one. Okay, so here's another one, same idea. Okay, so watch this one, and it's a little bit different. This one isn't a line. Okay, so they're saying here that I have what point that I'm going to plot?
0, 0.
I'm going to plot 0, 0. Then it says, what is my slope at 0?
0.
So I know it's horizontal right here. Let me use a different color. Okay. Oops, that wasn't the different color that I wanted. All right, so my slope is 0. Okay. Then it says, as long as my x value is not 0, what's going on with the slope?
It's bigger than 0.
it's bigger than 0. So I always have a positive sloped graph, right? So this one is a line again. So as long as, oh, you know it isn't. It's this thing. It's a cubic,
Whoa.
right? Because isn't that a positive slope line that has a slope of 0 here?
Oh, it's a line.
Yeah, it's a cubic. Yeah, you guys, when you're looking at these graphing things, you got to think the derivative dance in your head too. Okay? Not on this one in particular, but when we get to some of these other ones. Okay. All right, you ready for the next one?
Yeah.
Okay. So here comes the derivative dance. Okay? So sketch the graphs of f prime and f double prime. We can probably, I'm just going to do them below here. It's probably easier to separate them. So I've got a parabola. What is a parabola supposed to go to? A line. Okay, but let's think about what kind of line here. So we know it's at about -2. There is a 0, right? So I plot my 0 at -2, because that's where my slope is horizontal. Am I increasing or decreasing first? Increasing. So that means I am above the x-axis.
Wait, it's -3 though.
It looks like -1, not -2, huh? So watch how I fix that. There we go.
Whoa.
Okay. Had to erase less. All right. Then what's going on after my 0 here? It decreases, which means that my derivative is below the x-axis, or negative. Okay. Then this is the derivative graph. My second derivative, I look at this picture. I don't really have a 0 this time. I have a line. A line goes to a what? Think derivative dance. All lines are straight. Horizontal line. Okay. All right. But what's the slope of this line? Is it positive or negative?
Negative.
Negative. So your horizontal line is going to go below the x-axis.
Just like anywhere below then?
For right now, yeah, because we aren't exact, right?
Yeah.
This would be something where I'd probably have you match it, or multiple choice below, because your slope on this line is negative. Okay, it's decreasing. Okay. Yes, I know, but I loved when you guys do that, so because I can say all lines are straight. Okay, it's okay. Everybody does it at least once in here. Okay, so looking at this next one, where this is a cubic, right? Where's my 0 this time? Careful. Look at your graph. What's it scaled in? 2. So this is at -2. I've got my 0 this time, and I'm sure about that this time. All right. We notice that the graph is always what?
Positive.
It's always increasing,
Yeah.
which means that my derivative is always above the x-axis. Okay? And think about it. A cubic is supposed to go to a parabola, right? What does a parabola go to?
A line.
A line. Okay? So I'm going to have that same 0, aren't I?
Yeah.
It's going to still cross here. It starts by decreasing. So does that mean my derivative is above the axis or below the axis?
Above.
Below, because it is decreasing. And then it switches to what? Increasing, which means my derivative is above the x-axis.
So for the third derivative, it would just be a horizontal line.
Correct. If I had to go to the third derivative on that, it would be horizontal above the axis because it's a positive slope. All right, let's keep going. There's 2 more of those. They get worse, right? Okay. These two are probably very similar. Okay, so f prime, f double prime. These are actually, these are trig, aren't they? Yeah, so they're going to kind of go back and forth. So I have 2 zeros, one of them at pi over 2, right? And one of them at 3 pi over 2. Okay. My graph starts by doing what? Increasing or decreasing? Increasing, which means I'm above the axis. And then it decreases, which means I'm below the axis. And then I'm increasing, which means I'm above the axis. Now, it's a trig. It would really keep going. So basically, that one was a sine, and it's going to look like a cosine graph, right? But the piece of it that they showed us made it look more like a parabola, didn't it? So We could do again, halfway in between there is pi, isn't it? So that would be where our 0 is going to be. And then we are decreasing, so I'm below the axis. Increasing, so I'm above the axis. And really it should kind of keep going like that, but they didn't show us that much of the graph. So it should look more like a sine graph, but negative sign, right? Where it starts at -1. All right, looking at this one here. So it looks like my zeros are at 0, pi, and 2 pi, right? So 0, pi, 2 pi. All right, I'm starting by increasing or decreasing? Decreasing, so I know I'm below the axis. And then I go to increasing, so I am above the axis. And again, that one looks more cosine, so this one should look more sine. Actually, negative sign, right? And then I'm going to go from there, so I'm thinking halfway in between and halfway in between, right, is my zeros. I'm decreasing, so below. Increasing from here to here, so I'm above. And decreasing again, so I'm below. And again, it's probably going to do one of these things. Okay? It's periodic. All right, we good with those ones? Sort of. All right, we got to use the quotient rule to differentiate. So, what is the quotient rule? Low, D high. Okay, gotta keep them straight, right? So low, derivative of high is what? 1 minus the high, which is x. The derivative of low is 2x all over the low squared. You do not need to do anything else with it. That's it. Okay? If it's multiple choice, you might have to go further, right? But if it's not multiple choice, you leave it like that and you write it on your paper. You don't type it into the computer. Okay? All right. Which means if it's something like that and the limiting one, it's not going to score it automatically. So don't freak out when you see your scores tomorrow. Okay, like you did on the last one. All right? Don't panic. All right. What rule am I going to need this time? Product rule. Good. So we're going to keep the first. What's the derivative of the second? Cosine t plus, keep the second, sine t. What's the derivative of the first? 2t. Now let's pretend it's multiple choice. That's a great answer. Multiple choice, sometimes these test generators like to do this to you. What did I do? I factored out a t, right? I don't know why they insist on doing that, but sometimes they do. So I just want you to be ready for it just in case. So it could be either answer. Okay, if you're free response, you're doing this. Multiple choice, you may have to do that. Okay? What's wrong, Evangelique?
How did you even get that?
Derivative of the first. Oh, sorry. Keep the first, derivative of the second. Keep the second, derivative of the first.